Quadratic word problems. Today we're going to look at one type. I'm just going to call this type 1, and I'm going to call these rectangle word problems. We're actually going to be looking at rectangle word problems for a few days, and today I'm going to start out with some fairly simple examples. So let's say we have a problem like this. King Tut wants to fit 27 square centimeters of scrolls into a shelf. And the shelf is rectangular. He wants one side to be 6 centimeters longer than the other side.
We use the rectangular cube property, where all cubes where all squares are rectangles.
How long should the sides of his shelf be?
Did they have the metric system?
They did not have the metric system. However, the reason that I used King Tut is because quadratics were actually invented in ancient times to solve problems like this.
That's great.
Okay, very similar to this type of a problem. What I like to do with these, I told you that this is a rectangle word problem, so that's a hint. And I like to first draw a diagram here. And here's how I like to draw the diagram. We know that the area of this rectangle has to be 27. That's the area, right?
The longer side has to be plus 6.
Okay, the longer side has to be something plus 6, right? Which is the shorter side. So let's actually start with the shorter side. How long is the shorter side?
Minus 6.
Well, we don't actually know. So let's just call it x.
And then it'd be x plus 6.
And then the longer side would just be x plus 6. So all the problems that you do on your homework are going to look something like this. We're going to have a side which might be x. And then another side which is going to be something like x plus 6.
And then you just multiply
Where did I get the x plus 6? One side should be 6 centimeters longer than the other side. So I started with the other side and I made that x. That's this side. And then this side is 6 centimeters longer than x. So it's x plus 6.
Then you write it up like x times x plus 6 equals 27.
X times x plus 6 equals 27. Why?
Because
Because
the area is multiplying the two sides.
length times width equals area.
Could it also be that like the longer side is x and then the shorter side is x? I know, right?
Well, if one is x plus 6, that would be longer, right? But yeah, it doesn't really matter how you draw it. It doesn't matter at all how you draw it.
Wait, and then
Hey, guys.
it would be like x squared plus.
Not right now, please. Okay. All right. So now this is going to turn into a quadratic. But in order to solve a quadratic, we have to have it equaling 0. So there's some work we have to do to get this into a quadratic that equals 0.
Well, x.
The first thing that I like to do is expand this. This turns into x squared plus 6x equals 27. Okay, subtract 27 from both sides, and we get x squared plus 6x minus 27 equals 0. So now I have to try to think of factors of 27.
3 and 9. 3 and negative 9.
that add up to 6.
Negative 3 and 9. Negative
Yeah, exactly. So I have x minus 3, x plus 9 equals 0. I simply factor this into this. And now I can solve this.
Now or x equals negative 9.
X equals 3 or x equals negative 9. Now, we're asking about the sides of a rectangle. Can the side of a rectangle be negative 9?
No.
No. So we can get rid of that answer. We can cross that one out. The sides of a rectangle have to be 3 centimeters and 9 centimeters.
Oh, wait, why do you just use the negative? Does the negative not count?
Because we can't have the side of a rectangle being a negative number. If King Tut wants to build a shelf, he can't build a shelf with a side of negative 9 centimeters.
Could you just use logic and be like, oh, factors of 27, that one of them has to be have a difference of 6.
Yeah, so if you think about it, right, that is what we did.
I know, but that's a
Wait,
lot.
I understand it.
That is what we did.
Wait, but Nate, how do you write it? How do you